half angle identities. So we have sine theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. And here, depending on the quadrant in which this theta over 2 lies, we have to write the positive sign or negative sign. Similarly, cosine theta over 2 is equal to plus or minus square root 1 plus cosine theta over 2. And the tangent, to get tangent, you can either take the ratio of these two to get 1 minus cosine theta over 1 plus cosine theta square root, or we can also use this formula, sine theta over 1 plus cosine theta or 1 minus cosine theta over sine theta. Okay, let us look at this problem. Find the exact value of each. So you are looking for sine theta over 2. Already you know the value of cosine. Cosine theta equal to negative 4 square root of 2 over 9. And this angle theta is lying between 180 and 270. Having known the formula, sine theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 2. Let us decide on the sign first, whether it is positive or negative. We are looking for this angle theta over 2, in which quadrant it lies. Therefore, what I'll do is divide all three of them by 2. We can do that to give 90, and 90 degrees is less than or equal to theta over 2, and that is less than 135. So it is clearly stating that the angle theta over 2 is more than 90 degrees and less than 135. So you are in the second quadrant. In second quadrant, the sign is positive. So I'll just take the value of this, the formula, as just a square root of 1 minus cosine theta over 2i. It is positive, so I don't have to write the plus sign before this formula. Okay, so now I have sine theta over 2 is equal to square root of 1 minus cosine theta over 2, and here we don't have to worry about taking the Pythagorean theorem, a square plus b square equal to c square, find the third side like we did in the previous problems, and then find whatever ratios that are needed, whether it is sine, cosine or tangent, because already cosine value is given to us. Cosine theta equal to negative 4 square root of 2 over 9. And in the formula also I have only cosine. Suppose if that cosine is not given to us, then we have to use this process like we did in these problems. Like in 15th problem, what did you do? From sine you are looking for a tangent. So I have to go to the Pythagorean theorem and substituting for a square plus b square equal to c square. That long process, but you can do it. But in this case, we don't have to worry about it because it is already there. Okay, let me substitute the value 1 minus that cosine theta is negative 4 square root of 2 over 9. So this is the value of that 1. I just copied that 1. There is a minus sign. I got a minus. Cosine theta is negative of this whole thing. And in the denominator, I should have 2. This 2 is in the denominator. I should have extended this radical sign. Anyway, we can continue. The next step, what happens? This becomes square root of You know this 9, I can have this 9, that is in this fraction, in the denominator we have 2, and this whole thing is there in the numerator, okay? And this 1, you can assume that it is 9 over 9. 9 divided 9 is nothing but 1. So I can write 1 as 9 over 9. So what happens? These two have the same denominator, 9. So now on the top I have a 9 there, and negative of negative become plus. Because of the denominator 9, I just copy the numerator 4 root 2. So we handled this piece. The whole numerator is handled, and in the denominator you still have a 2. 2 is there in the denominator. So from this, what happens? Now these denominators and denominators numerator you can just multiply. I'll show you in detail, just in case. It is like 9 plus 4 root 2 over 9, and this big division became multiplication, so just one dot is enough for multiplication. In the denominator we have 2, so 2 you can take it as 2 over 1. So on changing this big division sign into multiplication, you know that I have to flip this 2 over 1 as 1 divided 2. Yes, simplifying fractions. I'm using that same old concept. So that gives you square root. That is 9 plus 4 root 2 times 1 is 9 plus 4 square root of 2. And in the denominator, 9 times 2, that is 18. Okay. Now, we know very well that in the denominator, I should not have an irrational number. So 18, that is square root of 18 is not available. In the denominator, I should have a perfect square so that I can get rid of the square root sign from the denominator. So we have to see with what I should multiply this denominator 18 to make it a perfect square. Alright, so let me write this again. I have 9 plus 4 root 2 over 18, and as 18 is not a perfect square, what is the least number that is available? Right after 1 I have 2. Let me multiply 18 with 2. 18 times 2 is 36. 36 is a perfect square because square root of 36 is 6. 6 times 6 is 36. Anyway, so I have to multiply this 18 by 2. And whatever you do to the denominator, you have to do the same thing to the numerator so that the value of the given expression, it will not change. We cannot change the value. Now, multiply these two numerators. So 2 times this whole expression. Using distributive property, 2 times 9 gives you 18 plus 2 times 4, that is 8, and square root of 2, of course, 8 root 2. I just multiplied 2 times 9, 18, and 2 times 4 is 8 root 2. And in the denominator, 18 times 2 is 36. So now we are almost there. You are looking for your sine theta over 2 is equal to, now I am separating the numerator and denominator. Numerator is still a square radical 1, that is inside I have 18 plus 8 root 2, and in the denominator square root of this 36 is a 6. So that is my answer for sine theta over 2. So let me quickly go back for a second and see, this is the formula. Substituted, mainly trigonometry is here. After using this formula, substituting, And all the simplification, we have to do it carefully. Just handle them carefully by making sure that you take all the negative signs into consideration, and here like irrational number, and right, simplified here, then big division becomes multiplication, reciprocal of that, and then multiplied, and then you handle that denominator 18. Okay, so this is your final answer for sine theta over 2. So in the same way you can find sine theta over 2 in this case. Here also you have cosine theta, so you don't have to worry about finding the third side. Directly substitute in this formula and simplify, you will get your answer. Okay, thank you.